Okay, now let's get started. Today's first topic is how to use CPCTC. CPCTC is meaning, does it have CPCTC over here? Oh, okay. I'm going to write down the CPCTC. That stands for, this CPCTC is what? Congruent part of congruent triangle are congruent. This is just C, P, C, T, C. Okay, that means what? Before you say CPCTC, you have to prove, right, the triangles are congruent. After that, you can say congruent part of congruent triangles are congruent. Okay, already this is the first. Now, second, you can say congruent. Corresponding part. Okay, corresponding parts are congruent. Okay, we're gonna try number 1 over here. Okay. Okay, that's the given. I'm gonna write down over here given. PTR, there is a line, and QTS also line. That's the given. Second one is TS congruent and TR. Okay, TS this side congruent TR is okay. These two sides. So triangle STR kind of isosceles, right? And the third one is angle P congruent angle Q. And these two angles are congruent. So this is already fixed one, right? Angles. And this is a side over there. So using these three given, they are given, we're gonna prove PS. Okay, this is where the PS this side. This is a circle. You're gonna prove this one. PS and QR. Okay. So how can you prove these two sides congruent? So after, anyway, we need to find the congruent these two triangles. This triangle, the other triangles are congruent because these two sides on these triangles are corresponding side. Okay, if these triangles are congruent, each corresponding side also congruent. Okay, that's our goal. Is it okay? Or you can take PSR, a triangle PSR, big one, and the other one. Okay, you can prove, right, these two triangles are congruent too. Is it okay? But I think this is better. Okay, we try this one. Okay, the first one we got already. This one. This is one angles already. This is side already. Okay, the method we have to go. What is that? Angle side. We call this angle is not given, but they are vertical angles. Okay, always vertical angles are congruent, isn't it? That is actually angle side. This one is angle side. Perfect. So we can go there. We already got one angle over here. You can circle. And one side already TS. Just to say these two angles are congruent. Okay? So angle PTS congruent, angle QTR It's very simple, okay? Not many steps. The reason is but you can just say vertical angles are congruent. That's okay. Just the vertical angles are congruent. Okay, many teachers they like that. But more detailed intersecting lines form or mid-intercept to form, or I'm gonna just write form is that's enough. Form, okay, vertical congruent vertical angles, or just vertical angles are congruent. That's fine too. Okay, now we got everything, which is what? Angle side. So you have to prove this one. We already 1, 2, 3, okay? Angle side. So triangle PST. Congruent. Triangle QRT. The reason is angle side. We're done. But after that, PS and QR is just like a part of congruent angles. So you can say go directly PS, this side must be congruent QR because they are corresponding side of these two triangles. This is corresponding side, this two corresponding side, this also corresponding side. So you can use over here after finish by congruent triangles, just to say CP, CTC. All right. Okay. Yeah, that's all, right? But instead of CP, CTC, you can write down, okay, congruent part of congruent triangle, okay, are congruent. You can use this symbol too. But it depends on the teachers, okay? Just a general, we use CP, CTC. It's okay. All right, we're gonna have one more over here. Okay, two more. After that, we're going into two triangle congruence. Okay, that is the hardest part of right triangle congruent. Okay, last week we did last times we did what overlap triangle. Okay, the hardest one is what two triangle congruence. Okay, now we're gonna try this one now. HAY, that's a straight line, okay? And the EAY, straight angle. Straight line there. This is given. Second one is HY. And EB bisect each other. So that means what line segment HY and the line segment EB, they are what? Segment bisector, okay? And the proof HE and the BY equals 0, okay? HE, this we're gonna prove this one. But before that, we already know that, right? These two triangles are congruent. Okay, we have to show that, okay? All right. HY, EB bisect each other. These two sides bisected. One side already. These two sides bisected again. And we have vertical angles there. Yeah, this one go to side angle side. Okay? So you can say HA congruent YA. Or you can put it in the same column together, okay? EA congruent AY. Okay? The reason is what there? Segment bisector, okay? Divide a segment into two congruent segments. Or two congruent parts is okay. But sometimes they use just two congruent halves. Okay, now we got the 2 over here, right? In this column, 2. The next one is the vertical angle is congruent. Okay, so angle HAE congruent angle YAY. This is VAY, okay? I'm sorry. This one is B over here. AB, okay? Yeah. Angle BAY. Vertical angle is congruent, okay? Or you can use by intersecting lines form congruent vertical angle. I'm going to use vertical angle congruent this time. Vertical angles are congruent. Okay, we got everything, right? Side angle, side. Now you can say triangle HEA, right? And congruent triangle YBA, they are congruent. This is number 4, sorry, number 5 is what? Side angle side. After that, HE and the BY, okay, they are corresponding side of each what? Congruent triangle, okay? So finally we can say that HE congruent BY. The reason is just to write down CP, CTC. That's all, okay? I hope you guys understand this one, okay? How we use CP, CTC, okay? CP, CTC always be, okay, always we need to prove, right, two triangles are congruent. After that, you can say CP, CTC, okay? Just one more step after congruent triangles, okay? Okay, one more question over here. Let me check. This is okay, a little hard one. I'm gonna use this one. Okay. To write down there. PRT and QRS straight line. And the second one is PQ perpendicular QS. PQ perpendicular QS. This is right angles. We got the one angle there, okay? And note in the same column is okay. TS and QS. Okay. So the third one is R is the midpoint. R is the midpoint. MP midpoint of QS. So QS R is the midpoint. These two lengths are equals. Right? They are congruent. So we got the side over here. So we need one more. Yes, there are vertical angles. This is what? Angle side angle is okay. Angle side angle is working, right? So we have to go this method. They are given. We already finished this one. Not finished yet. Okay, average is not finished yet. But using perpendicular, we're gonna say angle Q and angle SR. Only one angle there, okay? You can use only one letter, okay? If not, you have to say PQR, something like that, okay? But this is only one angle there. So angle Q and angle SR, right angles. Perpendicular lines form right angles. That's it. After that, we have to say they are congruent always, okay? Because we have to go angle side angle, we have to show that angles are congruent, okay? Angle Q congruent angle S. What's the reason? All right angles, because they said all right angles over here. Congruent. Okay, now we got the one down over here. The other one is one more angle. That's fine. We can go one more angle. Angle PRQ. Okay, this time we cannot say angle R, right? Because we have two different. So angle PRQ and congruent angle TRS. The reason where vertical angles are congruent. But at this time I'm going to use go this way, intersecting lines form congruent vertical angles, or vertical angles congruent. Just simply, okay? Now we got two angles there. Now we need one more side of it, okay, between these two. So you can say that R is the midpoint, QR congruent RS. The region is what? Midpoint divides a segment into two congruent segment or part or halves. I'm going to segment. Now you got everything. Angle, side angles. Okay, check it out. Angle, side, and angles. Okay. Now you can prove this one. These two triangles are congruent. Triangle PQR congruent triangle TRS. The reason is we got already this one. Side angle side. Am I recording this one? Just 1 minute. It's recording, right? Okay, it's recording. Okay. After that, now you can say the corresponding side are congruent. Okay. Where is the corresponding side? Angle P, angle Q. Corresponding angles anyway, not side. Angle P congruent to now angle T. CP, CTC. Corresponding part. Okay. It can be angle or side. That is okay. Yeah, that is the perfect solutions. You guys can figure out this one, right? Is it okay? All right. We need to go one more, or we can go two triangles congruence. Okay. Now let me see. Okay. This is not hard. Okay, just so we add by addition. That's all. Okay. It is not hard. Let me see the next one. Oops. I think, let me see, this is your CPCTC, not double congruence, right? Oh, very interesting. Okay, I think this number 4 belongs to double congruence, okay? Double triangle congruence. Okay, try this way anyway. Using anyway, that's gonna be CPCTC anyway. Okay, this we said double or two triangle double congruence. Okay, the first one is AEC. These two lines are straight. Okay, that's why angle 1 and this side is what complementary. Okay, supplementary. I'm sorry. Angle AC, angle BED, straight line, and AB congruent, AD, AB congruent, AD. These two sides, they're congruent, they're done. Third one is BC, congruent DC. BC congruent DC. This is already done too. I think so. This is a given. Second is a given. Third one is a given. But we try to prove right angle 1, angle 2 congruent. Okay? But these two triangles, these two angles belongs to a triangle ABE and angle ADE, right? So to prove right these two triangles congruent, you got only one side. This one may be another side, okay, reflexive, but we need one more, nothing else, okay, only two sides, okay. We need one more factor, but not given in the figure, right? So we have to go the other way, okay? So using big triangle, triangle ABC, and triangle ADC, we're gonna prove these two triangles first. From here we get the one more factors. We got only two over here, right? Okay, reflexive and this side. We need one more. This one more. Okay, we get it from these two triangles congruent. Okay, not this one. This one, big one, ABC, and this one. Okay, now take them out. So first we're gonna prove, okay, the triangles congruent inside there. Okay, we already got two sides. This side, this side. We need one more side, this one, AC, all the way, okay, from A to C, that is reflexive, okay, so AC, reflexive, another AC, they are congruent, this is the reflexive property. Okay, from here we get one more corresponding congruent, okay, all right, now take a look. Anyway, the triangle ABC congruent ADC, right? That it was the first triangle, side, side, side. It's okay? All right, that is side, side, side. This triangle is congruent. Now after that, take it out. To prove right these two triangles, because angle 1 and 2 belongs to these two triangles, you got already one side over here, okay, already over here, okay, AB. We still have an AB there, and we said AE, isn't it? We just saw the way AC, but we have to say AE one more times. So okay, so AE congruent AE, right? But we just before we use up to the A to C. So anyway, this is a reflexive also. But sometimes we can use this one, we can write it twice these times, because if this belongs to a triangle, right triangle, this triangle, okay? Okay, but if you want it, you can write that one more, number 7 is AB, okay, congruent AD, already you have to use, okay? This is why it is used to prove right triangle ABC congruent ADC, okay? But you don't have to already this one. You can use still number 2 in there, okay? Okay, anyway, AB, AD is congruent. The next one, AE is congruent reflexive. We got two sides. We need one more, okay? What about this angle? Just before these two triangles from here, this angle, the other side angle is a congruent angle, corresponding angles, okay? So you can say angle BAE, okay? Congruent angle DAE, okay? This you can use CPCTC, okay? Now we got the side, another side, angle. What is that? Angle, side, angle side, okay? Second one is we have to go method is side, angle side, side, angle, side. That is okay? All right. So using this one, we have to say now triangle ABE, okay? Triangle ABE. Congruent triangle ADE. Isn't it? You can see that number 5 congruent to number 8 congruent, different triangle, okay? This we said double congruence. Okay, this is not A. Okay. The region over here, side angle side, okay? Side angle side. Just before side, this time side angle side. Now from these two triangles congruent, now we can say angle 1, angle 2 corresponding angles. This angle corresponding angles, okay? You can say angle 1 is now congruent to angle 2, okay? You need one more time, CPCTC. Okay, we're done. Okay, so you can see, right, number 5 and number 8, two triangles are congruent. Okay, this we said double congruence proof, okay? This is a hard one. We can go directly, okay, prove this way. We have only two factors available. We need three, right? So one factor can be obtained from here. Okay? So total is three factors. Okay? Side, angle, side. That is double congruence. So we're gonna have a more practice on double congruence. Okay? Over here, now going into double congruence. Okay, here. MST, straight line, and the number 2, MA, congruent, MH, MA, congruent, MH, and then AS, congruent, HS. These two sides congruent. It's already two sides over there, okay? So we're gonna prove, right, MT bisect ATH, MT bisect a angle over here, okay? We have to show that, right, these two angles are congruent, okay? Then MT is what, angle bisector, right? We can prove this one. From the given, we only said what these two triangles are congruent. It's okay? Okay. How can you, which method we can go? This side, another side. Yeah, reflex of another side, right? First, we can go side, side, side first. That's the first, okay, congruence, okay? We already got over here, MA and the AS equals to HS. Now, reflexive MS, okay? MS last side, MS is congruent to MS. All three sides already. 1, 2, 3, 4. This is a given. This is a given. This is a given. This one is reflexive. Now we can make conclusion. Okay, the triangle AMS, congruent. Triangle HMS. The region is what? Side, side, side congruent. Okay, from these two triangles congruent, what we got for triangle, what is that? We have to say, right, this line is what is that? Bisect angle. So we have to go this way. This angle, this one is now triangle, okay? So you can say these two angles are congruent. Is it okay? They said MHT already, okay. We better make it simple, okay? Because they said MHT is a line, okay? That's fine. Now I'm gonna go this way. These two triangles congruent, what I got? This angle, the other angles are congruent. Let me see. I'm gonna go this way. A little easier, okay? You gotta go this way, okay? This angle 1, angle 2 are corresponding angles, okay? Then we can use side angle side, okay? All right. Now from here, angle 1, I'm going to do the angle, okay? Angle AMS. Angle AMT or AMS, it doesn't matter. You can use anything, okay? AMT congruent angle HMS, okay? The reason is what? CPCTC, isn't it? Corresponding angles. These two angles are congruent, okay? Now we got one angle over here. One side over here. To prove, right, these two angles are corresponding, okay? So we have to say, right, this triangle AMT must be congruent triangle HMT. We have to show this one, okay? The large one, okay? AMT and AMT, so this is corresponding angles, okay? So we got already AM, okay, one more over here. We got already over here. Okay, MA equal MH. And we got one angles already. One angles. Now we got one side along the all the way over here, right? There is another reflection. So right down there. MT congruent MT. Okay, that is reflexive. Now you can say triangle AMT congruent triangle HMT, right? What is that? Side, angle, side. It's okay? The next one is side, angle, side. We have to go side, angle, side. It's okay? So you can say now triangle AMT. Oops, we did already. I'm sorry, this is angle, okay? No. We did over here. Okay? After that, corresponding side, okay? Angle ATM congruent angle HTM, right? Because these two angles are congruent. Okay, there is another CPCTC. Because these two angles congruent, MT must be what? Bisector angle ATH. Now we make conclusion, okay? So MT bisect angle ATH. Bisect, right? Because this is from here. They're equal, okay? That's why they are bisect angle. So what is that? Same as before. Angle bisector divides an angle into two congruent angles. Okay? You can use the same region. Okay? That's it. That's all proof. Okay? This is also, we can see that one triangle congruent, another triangle congruent. Okay? Double triangle congruence. We said just simply what? Double congruence. Okay? Okay, after we try number 3, we can go back number 2. Okay. Okay. We're gonna have some break. Okay. Let me see. I'm gonna go this one. Okay. Question number 3. Okay. Take a look at question number 3. Okay. Why this is called double congruence? Okay. This is a proof. BA congruent to BC. We're gonna prove where is BA. These two sides. We're gonna prove this one. Okay. So using corresponding. So these two sides belongs to what? ABC, which is what? Triangle ABE and the triangle BCE, right? These two triangles. Okay. But in this case, angle 1 and 2, angle 1 and 2 is what belongs to the other triangle. Only angle 3, angle 4, only one is available over here. Okay, to prove right these two triangle ABE, triangle BC congruent, we need one angle is given. The other one is maybe reflexive. So we have one angle, one side. Okay, we need one more. Where is one more? It's not given, right? So we're gonna find one more from the other triangle congruence. From here, angle 1 and 2 congruent, and this one is what is there? Reflexive. Okay, angle 3 and 4 is given already. From this 3 and 4, you can find what these two supplementary angles congruent. So this one can be proved, right? This triangle, the other side of the triangle must be right there. Angle, side, angle. Using first one, angle, side, angles. Angle, side, angle. So triangle AED, congruent triangles CED must be using what? Angle, side, angle. Using this one, we can prove right these two triangles are congruent. After that, you decide. Now, this is a corresponding part, right? Corresponding side of the other on this triangle must be equal. So this we have another side. So now we got everything. Side, angle, side. Okay. Second one is what? Triangle ABE, congruent triangle CBE must be going into this way. Side, angle, side. After you finish these two triangles are congruent, now you can say the corresponding sides are congruent using CP, CTC. Okay, that's why this is called a double congruence. If we can go this one, prove this one directly, okay, we have only 2 that is not given, or that is not 3. We need one more, okay, to get what one more factors, we have to use with the other triangle congruence. Okay, that's the idea. Okay. Okay, now using BED, the straight line, and the angle 1 congruent to angle 2, and angle 3 congruent to angle 4. Using this one, we're gonna try to prove these two triangles are congruent. Triangle AED and triangle CED. These two triangles are congruent. Okay, this one easily we can congruent. You can prove this one. Okay, all right. Angle 1, angle 2 is already got. We have the one angles already. Okay, side is given. I'm gonna put this one side first. ED congruent to ED. Okay, that is reflexive over here. 1, 2, 3, they are all given. Okay, that is reflexive. Now we need one more over here. We need this angle, right? Okay, I'm going to this angle is 5 and 6 is okay too. I'm going to 5 and 6 to make it simple. Okay, 5 and 6. So we can see that because this is B, the straight line, Angle 4, I'm sorry, not angle 4, angle 5. Angle 5 is supplementary. This one, I'm going to use to adjust soup, simply, okay? Angle 5 is soup to angle 3, okay? And angle 6 is a supplement, just a soup to angle 4. It's okay? All right, because what angles that form a linear pair. Do you remember this word region? A linear pair forms what? Supplementary angle. Okay. That's it. Okay. Now the next one is angle 3, angle 4 congruent. These two angles we know the congruent. So it's a supplement also congruent. Okay. So angle 5 congruent to angle 6. Supplement of congruent angles are congruent. Okay. Now we got everything, right? You can say triangle now A, E, that's over here, AE, right? Okay, that's 5, 6. Angle AED, congruent triangle CED. Okay, the reason is what is that? Angle, side, angle, okay? Angle, side, angle, congruent. Okay, sometimes we can give the region. This one is from where? From angle 1, 2, from number 3, and number 4, reflexive, and number 6. Sometimes we can give the region of number, okay? 3, 4, 6. Now there's from these two triangles congruent, we need to find one more, okay? Now take a look of it. We just finished this one. Angle 3, angle 4 is congruent. One angles. Side angles. We need one more. This side, okay? This is corresponding side. Okay. So you can say go this one AE segment congruent CE, okay? This is actually CP CTC. Okay? 3 and 4 is given. Now we have to say BE equals to BE, right? Using reflexive. We have to say this one, okay? BE congruent to BE reflexive. Now we got everything, right? Angle 3 and 4, number 3, and well, the number 3, 3 and 4, and BE, number 9, and the AE, AC, okay, AE, EC, right, AE, EC, that is the number 8. From this number, we can say triangle ABE, congruent triangle CBE, okay? From these numbers, 3, 9, 8. The region is side, angle, side. Now we're done. Now finally we can say these two sides, okay? BA, BC, corresponding side on this right triangle, right? Okay. BA, BC, congruent to BC. Yeah, this is also what the CPCTC. Okay, you can see that number 7 and number 10. Okay, and this is our main. Okay, this is a supplement. Okay, so to solve right triangle ABE congruent triangle CBE number 10, we need help from this triangle congruent. Okay, we need one more factor. Okay, that is a double congruence. Okay, we're gonna have one more over number 4. Now RST is isosceles. RST. This is isosceles means what? These two sides must be congruent. Alright, we have to show that. We have to prove, right? RS congruent TS or STS. Okay, SR is better. SR congruent ST. Alright, so that is RST is isosceles. But it's not given over here. They said only given is RETE inside. Okay, and the SEM, there is a straight line. M is the midpoint, means what? These two sides is equals. Okay, but how can you prove why these two triangles, these two sides, you prove this one congruent? You have to prove this one. That means what is that? This two side belongs to these two triangles, right? Okay. After that, you can say these two sides, corresponding sides, are congruent. Make sense? Okay. Or you can, okay, there are several ways, okay? There is not only one way, okay? Sometimes we use this big triangle. The other triangle also belongs to the corresponding side, okay? This already we got. Midpoint, okay? And what else? This corresponding side, isn't it? This angle, corresponding side. And this another reflexive that is equals to a side, angle, side. You can go this way too. Okay, this time I'm gonna go right the largest triangle, okay, not okay, smaller triangle, okay. If you wanna go right small triangle, this one and this one, this corresponding side congruent. Okay, this is congruent already. So M is midpoint, this corresponding angle is congruent. Corresponding angle is congruent is why it's a supplementary is congruent. So this side congruent, supplementary, another side, it goes to a side angle side. You can go this way too. But I'm gonna go this way, the big triangle, okay? Triangle SMR and SMT. Okay? Alright, now let's do it this one. RE congruent T. This is already given. SEM, straight line. And number 2, M is the midpoint. Of RT. Now I'm gonna prove right these two triangles are similar first. Okay, alright. So we got the one side there. And midpoint, another side over here, right? They're gonna be equal. I'm gonna write this one. So RM congruent TM, right? So midpoint divide a segment into two congruent segment, or I'm going to this one, I'm going to use a part. Okay, we need one more. Okay, so EM, it's okay. EM, this side reflexive. Okay, this side of this triangle and this side of the other triangle, they are equal lengths. So EM congruent EM. EM reflexive. It is okay. All right. Now we got everything. Okay, side, side, side. So triangle REM congruent triangle TEM, right? This is the first triangles. Side, side, side. It's okay. Okay, after that, we're gonna use right given this one already. We're gonna use this one, and we're gonna find this angle and reflexive over here, right? Largest one. Okay. So this angle E. Okay, I'm gonna use what SM. Same angle. You can use EMR or SMR. Okay, they are equivalent. Okay, so you can use anything. So angle I'm gonna use what RMS. Angle RMS congruent. Angle TMS. This is what CPCTC. It's okay. They're congruent. Each one is the right angle. We know that. Okay. Now we got the side already. Now we got the one angle already. Now another side. There's a side angle side. Okay. So you have to say this one SM congruent SM reflexive again. Now we got everything. Okay. Side angle side. It's okay. So where is the number? RMMT number 3 and the angle RMS number 6 and number 7, all 3. Okay, now we can say triangle RSM congruent triangle TSM. Okay, from these 3 numbers. That is, what is that? Angle side angle. Okay, side angle side. Just the side angle side is okay. Now finally we can say large triangle. Okay, congruent. And these 2 sides are what? Corresponding side are congruent. Okay, so you can say SR congruent ST CP CTC. But we gotta prove, right? Triangle RSD, largest triangle, is isosceles. Yeah, these 2 sides is equal. Okay, 2 congruent sides. You can say now triangle RST is isosceles. The reason is what? This is isosceles because what? 2 congruent side, 2 congruent leg or side is better. I'm not going to use the leg, okay? So isosceles triangle. Okay, also in isosceles, you can use this one too. In isosceles triangle, okay, I'm gonna go formal, okay? Just isosceles triangle have 2 congruent side, or you can use the legs equal. It's okay too. Okay, that's why this triangle is isosceles. Okay. Yeah, that is 2 congruents. Okay. Okay. We're gonna go right there. The hardest one looks like the hardest one here, number 2. Okay. All right. ED congruent EF. Where the ED, these 2 sides EF congruent, and the EH congruent EZ. EH congruent EZ, this side, longer side congruent EZ, that's the given. And also one more over here, angle 1 congruent angle 2. This angle congruent this one. But we're gonna prove by triangle DJH, this triangle congruent. Okay. So how do we got the congruent? Nothing. That's right. maybe if you prove right this triangle EDH, okay, EDH, this one EDH, and triangle EGH, this is easy way, right? Side, angle, side. This is side, this is angle, this is side. Using this one, we can prove this one. Okay. But from here, what can you say? Its corresponding side are congruent, right? So I'm going to different color over here. This is corresponding side, isn't it? They are congruent. Only one there. Where is another one? Where is another one? This one is a little hard, okay? Because what? These two sides congruent, its opposite angles also congruent. Is okay? This opposite side also congruent. And also these two angles are corresponding angle. Using CPCTC, they are congruent. Okay? So using subtraction, find you got what? 3 and 4. Okay, now we got another angle there. So we got the one side, one angle over here. Where is the next one? Where is the next one? This is a lot of work. Okay, I just want to explain, okay, how to prove this. I think this is too much work there. This is a corresponding side, okay, EH, and EG is already given. It's okay, it's already given. And using this side, these two angles are congruent, right? Because what? Angles opposite congruent side still congruent. These two angles are congruent. Using this one, its opposite vertical angles congruent. It's okay? It's okay? So what I got? Side, angle, side, angle. What is it? Angle, angle, side. Okay, you can go angle, angle, side. Yes? This one is a lot of work. You understand, right? These two sides congruent, opposite angles of congruent, okay? The angles opposite of congruent side are congruent. You have to use this one 2 times. Okay? You guys want me to do this one? Okay, let me see. What is this? Okay, which one? Okay, this one? No, not this one, right? You said this one? It's okay. Okay. I'm not gonna do this one, okay? Because that is too much work. Okay. I don't know. If you are interested to that, maybe after finish your class, okay, you can prove by yourself. You can email it to me. I'm gonna check it out. Or anyway, after class, okay, I'll prove this one myself. Okay, Okay, when I finish my proof, okay, I'm gonna send out this via geometry unit 6 class note. Okay, I'm gonna send out to your email. Okay, you can take a look. Okay, all right, because this will take too much time. Okay, when I finish with the proof this one, I'm gonna send out this class note to your email. Okay, all right. We have another one. I don't think we need this one. Okay, okay. Just go over the next one over here. This is review section. Over here, we have one probe over here. We're gonna try this one, okay, today. Okay, another one over here, number 15 and 16. Okay, after this, we'll finish our geometry class. Okay, this is all right. The given over here, I'm going to black. BG congruent CH. BG congruent CH. AH congruent DZ. Where is AH? From here to here, right? AH DG is fine. This is a given. This is another given. So third one is AB congruent to BH. Okay, and for another one is the DC congruent to CG. Okay, I'm gonna this is the same color. Yeah, I need enough space down there. DC congruent to CG. Okay, so we're gonna prove, right, triangle EGH isosceles. Okay, to prove isosceles, what do I know? These two sides congruent. How can you find these two sides congruent? Oh, it's a little hard. All right. From this triangle ABH, triangle CDH, okay, from these two we can find the corresponding side. There's no corresponding side. Only maybe corresponding angle is okay too, right? Corresponding angle, isn't it? When you separate this one, this angle, these two angles are corresponding angles. They are congruent. Using these two angles, we can say these two opposite sides are congruent. Okay, that's our goal. Okay, anyway, we're gonna prove, right, triangle ABC, not ABC, ABH, congruent triangles DCG. DGC. Okay, we have to prove this one. First one, AH. This already got one side. This one side already. Okay, hypotenuse or side, we don't know. Okay, but this is a right angle. From here, this is reflexive. You can, using addition, you can say these two sides are congruent. It is okay, but the rest of them, this angle is not given. This angle is given, right? That is actually right. Angle, side angle, side angle is not working, but this is working because what, these two triangles are right triangle. Okay, that means we have to go HL over here. Okay, when you get the side angle, check it out. If this is a right triangle, we can go HL. If this is not right triangle, we cannot prove that. So from here, we can prove. Okay, first one, we have to go HL. We have to say what these two triangles are right triangle first. Okay, so angle B and angle C are right angles. Okay, perpendicular lines form right angles. But you don't have to prove that they are congruent. We have to go by HL, okay? So to use HL, we have to say these two triangles are right triangle. So triangle ABC, ABH, triangle ABH, and triangle DCG are right triangles. The reason is what? Right triangles have a right angle. Okay, just a right triangle has, okay, right. Has a right angles. That's why they are right triangle. Now you can go AH, this is hypotenuse, and we can say these two, right? Another leg, okay? So BH equal BH, GH congruent to GH. That is reflexive. So we have to say these two lengths are congruent, okay? Using the additions. Because of BG already over here. You can add these two, okay? So 1 and 6, BG plus GH congruent CH plus GH. Okay, that is the addition, okay? Now the next one is using the partition postulate. Okay, partitions. BG plus GH is what? BH, isn't it? So BH exactly equals to what? BG plus GH. And the next one is CG exactly equals to how much? CH and plus GH. That is a partition postulate. Okay, whole is equal to the what? Sum of each part. Or a part is what? Sum minus the other part. Okay, they both were partition postulate. Now replace with this one, okay? BG plus GH is what? BH. Okay, sorry there. Now we can say BH congruent to CG, okay? Substitutions. Just okay, substitution of congruence, okay? Now we got everything. This is the leg, this is the hypotenuse. These two triangles are right triangle. Now you can say triangle, these two triangle ABH, triangle ABH, congruent triangle DGC. The region is what? The HL, right? Because what? Right triangle, number 5, and the BGCH hypotenuse 1 and 5 and 9, okay? 5 is what? These two triangles are right triangle, okay? Now you can use HL, that's one, okay? After that, we can say angle G. I'm going to use this one, angle EG, okay? This is corresponding angles, angle EGA. I'm going to use this one, angle 180 in case, okay? Make it simple. Angle 1 and angle 2 are congruent. Angle 1 and angle 2 are congruent. The reason is what? CPCTC. It's corresponding angles. Okay? Sometimes you can use this number by your own. It doesn't matter. Okay? You can define this one. Angle 2, angle 1, angle 2 congruent. By our definition is what? Isosceles is what? Congruent two sides. So we set EH congruent EG, right? The reason is what? The side opposite congruent angles are congruent. Okay? Opposite angles congruent. These two are congruent. Opposite side must be also congruent. Using this one, we can say the triangle EGH is isosceles. Triangle EGH is isosceles. The reason is what? Isosceles triangle have or had or have, I don't know, have congruent side. That's why that triangle is isosceles. Okay, yeah, that's your perfect solutions for these questions. I guess okay with this. Just try to get used to. Okay, when you go to college, okay, there is some proof looks like this one. Okay, what is this? The title name is a discrete. When you take a look, discrete systems. Okay, a lot of proof in there. So if you don't build right strongly in this concept, a lot of trouble. Okay. All right. Now move on number 16. Okay. After this, we finish. I think. AH. I'm gonna make big. When I post this on YouTube, some students they want me to write make a big. Okay. AH congruent AG. This is G, right? Yeah, one side. And HB congruent GB. HB congruent GB. These two sides. Okay, using this one, H is inside. Okay, H is inside. So you can choose what this triangle, or this triangle. It doesn't matter. Okay, you can choose any triangle. I think it's okay. I'm going to the first triangle, these two. So anyway, okay, using this one, we need one more. Okay, one more angles there, because corresponding. It is only one side. It is also one side of this triangle. Another side over here, get reflexive. Maybe we need to find these two angles, right? Corresponding angles are congruent. So we're gonna go, right? The largest triangle. Can you see that over here? Triangle. I'm gonna make some more. Triangle ABH. Congruent triangle ABG, right? You have to prove this one. So we already got over two sides over here, side to side. We need one more side over here, AB congruent AB. That is reflexive. Number 1 and 2 is given. Okay, now you can say triangle AHB or ABH. I'm gonna write down ABH. ABH congruent ABG, right? The reason is what is that? Side, side, side. I need looking nice. Side, side, side. After that, corresponding side angle, I'm going to choose the angles. I'm going to choose the angle 1 and 2. Angle 1 congruent to angle 2, right? CPC, TC. Okay. Now we got the one side already before, and one angle over here, and we need one more side. That is a side angle side. Okay, we need one more side up to here. AE reflects AE. Okay, that is reflexive. Okay, we got one angle already, number 5, and the AE, and another one is the AH over here. Okay, from 1, 5, 6, that is a side angle side. Okay, now from here we can say triangle AHE congruent triangle AGE. The reason is what? side angle side. Okay, the first time it was a side, this times side angle side. Using side angle side, finally this corresponding side are congruent. So you can say HE congruent GE. Okay, this is we set CP CTC. That's done. Okay, this is the perfect solutions. Okay, I think we are done today. So after I finish, okay, I have another class now. After I finish this one, a little hard this one over here, okay, as I told you before. This one is the hardest one, okay. Okay, when I finish this one, I'm gonna send out this Unit 6 class note and with my the video. Okay, I'm gonna post the video, okay, after class. Okay, all right. So I want to thank you guys for these summers. Okay, I think you guys, okay, have some idea about geometry. Okay, we couldn't finish all subject or okay topics we can't. Okay, I try to make it around 70 to 80%. But actually, I think I did around 70 or 60 to 70% only. Okay, because we didn't finish the circle and quadrilateral proof. Okay, all right. Maybe you can do that. Okay, in your school curriculum. Okay, all right. So and also remember over here, proof is depends on every teachers. Okay, sometimes some teachers want to go right each going. Some other teachers is they usually like these regions, okay, in detail. But anyway, you guys follow your teacher style. Okay, all right. So I hope right you this summer geometry is a little help, okay, to your okay school geometry, okay, new semester. Okay, thank you so much. Okay, all right. If you guys have any questions, okay, during your school year geometry, you can email to me. Okay, maybe I can do my best, right, to help you guys out. Okay, all right. Thank you so much. I'll see you next time. Okay, if you have a chance. Okay, thank you so much. Everybody have a great the rest of the summer. Okay. Thank you. Bye, everybody. Okay, thank you, Catherine. Okay, I'm gonna recording. Where the recording stop?